welcome everyone. So for the few minutes I have met with him, Mitchell strikes me as a thinker at heart. He has a home love of Dell mini PCs, but also enjoys normal tech pro stuff like woodworking. Aside from that, maybe Mitchell is most well known for tools like Wallaby and the Elixir Beam plugin. Today, Mitchell is presenting yet another tool. He's here to present us an effort to unify all the Elixir language server protocols into a single one, the official Elixir language server protocol. So let's give a warm welcome to Mitchell Hanberg.
Hello, thank you. Keep it going, yes. Can you hear me, everyone? Okay, cool. Yeah, so really thank you for having me, everyone. It's an honor to be here. I'm here to talk to you about the state of the Elixir language server situation, kind of answer some questions I know a lot of people in the community have had of what's going on, what's the current state, how's the progress going, what can we expect. And I think you can expect great things, so I'm here to talk to you. Who am I? Mitchell Hanberg, you can call me Mitch. I'm a lead software engineer at DraftKings. I'm a founding member as of last year of the official language server team. I'm the author or maintainer of a wide set of Elixir open source libraries like Wallaby, Temple, the Elixir tools, set of developer tools like NextLS and NeoVim plugin like was mentioned earlier. And I've been working with Elixir since about 2017, and I like to say I went pro in 2020. Really want to thank DraftKings for allowing me to be here, sending me out, and sending out a bunch of our team to support me and help recruit. So just a brief thing on DraftKings. We're a digital sports entertainment and gaming company creating a differentiated and dynamic consumer experience through an ecosystem of next-gen products and technologies. We have over 5,200 employees nationwide, Europe, Israel, US, Uruguay, Brazil. And DraftKings recently acquired SimpleBet, which is where I come from, and Jackpocket, two companies using Elixir and are active in the Elixir community. So thank you, DraftKings. Last time you saw me, I was here at CodeBeam 2022, talking about things very similar to what I'll be talking about today. In my talk, OTP process abstractions with Proclib, we together built a mini version of a Credo language server using the same process primitives as modules like the gen server and supervisor and gen event that are built right into OTP. So that kind of starts my whole journey on this whole dev tooling kind of officialness. So let's move on to just kind of some, the overall theme of this talk is updates on the Elixir LSP project. So what we can expect is a recap on the language server protocol. Just some of you might not even know what it is. You just use Sublime Text and you don't care. Some history on just kind of language server support in general, kind of the recent developments in the last couple of years that have brought us to how we are today. Updates from the official language server team, and hopefully something exciting at the end. Not too exciting, don't get your hopes up, but kind of exciting. So what is the language server protocol? It's a protocol that came out of Microsoft and grew out of the text editor Visual Studio Code. It's a JSON RPC messaging protocol for text editors to communicate with a language-specific intelligence server. It communicates with that server via standard I/O, TCP, or Unix pipes. Examples of language server protocol implementations are Elixir LS, which I'm sure you're all familiar with, things like Go Please, that's how I say it at least, Rust Analyzer. And kind of the whole purpose is, they like to phrase it as this M plus N problem, where you've got M text editors and N languages, and each text editor kind of before was implementing their own support for every language. So you've got individual editor plugins all implementing the same thing. So this kind of, the protocol is just this common language that a client is the text editor, and a intelligence server can speak between. So you can make one Elixir server talk to any editor, and then do that for Gleam, Erlang, Rust, what have you. So why I'm here is I'm on this official team, and what kind of brought us to having a team of multiple people. Well, we had multiple language servers. So let's talk about language servers, plural. We started with Elixir LS. In the last couple of years, we have just seen a ton of development in this IDE tooling space, resulting in 3 implementations of the same language server protocol. So the protocol is made so you're not re-implementing the same thing for every editor. Well, we eventually had re-implemented the same kind of protocol 3 times for one language for all editors. So Elixir LS, Next LS, which I made, and Lexical is the other one. So we'll just kind of give a brief history. A lot of people know a lot about this. Some people don't, so we'll just kind of make sure everyone's on the same page. Elixir LS is the original language server. It was created by this guy named Jake Becker around 2014. This was kind of around when the language server protocol was really being pulled out of VS Code. Before, it was like a built-in protocol for TypeScript, and even the TypeScript language server today still uses that kind of like off protocol. But development kind of slowed around 2019, whether that's because Jake Becker did open source development. He can do whatever he wants. He can stop if he wants, or moved on from Elixir. It doesn't matter. Slowed down a little bit, but luckily around 2020, it was revived by a number of people, but primarily by Lukasz Sampson and Jason Axelson, who's here and gave a talk. It was really good yesterday. Thank you, Jason. So I'd say please clap. As our boy Jeb likes to say, really that was a pinnacle, a pivotal moment in kind of like the DX history of Elixir, and can't stress enough about how great that kind of event was. There we go. Elixir LS, provides autocomplete, go to definition, find references, all those types of IDE features you'd expect if you came from like Visual Studio, JetBrains style editors. Development really ramped up kind of mid-2022. Lukasz really was just putting his all into it at that point. And a lot of features from Elixir Sense are powered, or by Elixir LS are powered by this library called Elixir Sense, which was started by Marlis Saraiva, which is one of our coworkers at DraftKings. Great guy, does a lot of other open source work. And to give you kind of a sense of scale, as of whenever I wrote this slide, the Elixir LS VS Code extension has over 622,000 concurrent installs. So maybe that's not active users, but that's how many VS Code instances have this plugin installed on it right now. So that's also just crazy. There's that many people who have been at least interested in Elixir or write Elixir every day. One of the other language servers, Next LS, this is the one that I made, started by me, mid-2022, real development on it kind of started mid-2023. I kind of branched off and started my own thing because the architecture of Elixir LS kind of had seen some age and wasn't really conducive to new development. Really wanted to innovate and experiment in certain areas and not be slowed down by kind of just messing with someone else's project. Like I wanted to just kind of rapidly try things out, throwing them away, experiment. So far from our GitHub releases, which is where it primarily is downloaded from, has been downloaded over 38,000 times. And the ideas kind of started with Credo language server, which we built the prototype for in 2022. And kind of between then and when I really ramped up on Next LS is when a lot of the innovations and technologies and foundations were being built over. And we'll talk a little bit about that later. And to go over Lexical, started by Steve Cohen in early 2023. So like Lexical, Next LS kind of started really around the same time. We had no clue about the other one. And Elixir LS had also kind of been seeing some more movement kind of around the same time. Conceptually, Lexical actually started as an experimental server in the Elixir LS repository. Kind of also wanted to innovate and test things out, but doing that inside another project and changing things is just not fast and fun. So Lexical has been downloaded over 21,000 times from their GitHub releases. I think a lot more people compile it from scratch though, so you can probably bump that number up a lot. So we're talking about make some new ones, new language servers. We want to innovate, so let's talk about innovation. Like, was it worth it? Should we have just stuck to the Elixir LS? I think so. So with NextLS, I created several libraries and abstractions kind of between working on my last talk here and kind of really starting on NextLS. I created GenLSP. That's kind of the core of what we built in the last talk. That's a process abstraction and LSP implementation for creating language servers. So all the data structures are generated from the protocol, and it implements all the valid transports that you want to use. It kind of just hides all the LSP stuff you don't really want to worry about while you're actually building your implementation. I built this library called Schematic. It's used for data transformation and validation. It's used inside GenLSP. It's similar to libraries like Norm, or even you could say ectoschemas, in that you can describe your data and put data through and unify it, and it gives you errors, and it can convert map keys from whatever you want to whatever you want, strings to atoms, whatever. And also, I built this new Elixir parser called Spitfire. It's error resilient and has a macro environment expander inside it. So the error resilience is good for when you want to know where you're at in a file, but you have a bunch of botched code that's incomplete underneath, and you don't want all the IntelliSense to not work because you have syntax errors. The symbol and reference index in NextLS is actually built by compiler tracers and stored in a SQLite database used through NIF. And the whole thing is packaged into a single binary executable through this library called Burrito, written by our friend Digit, who gave a nice talk on Flutter earlier. We've gotten really close through this library. And one of the most notable differences between the architectures is NextLS uses multi-node architecture versus all being one Beam instance. And we also have concept of extensions, and there's currently just Credo extension, just so your Credo linting rules. Lexical, likewise, has been innovating a lot. They also have the multi-node architecture. One of the most innovative things in my mind is this clever namespacing solution for injecting our language server code into your project code in this other node, but it not having it clobber your code or show up like our dependencies in your autocomplete, or just even if you're working on the language server itself, it's not recompiling itself, so it will break and then your whole thing can't work. They've had a heavy focus on speed. They've made innovations with their completion system, and kind of it knows where you are in the file and what kind of completions you might even want. They have as you type compiler diagnostics and just all types of files, so it just shows you, you don't have to hit save and wait for it to compile. It kind of just compiling all the time. It also uses CodeGen from the protocol, and they also have a concept of plugins and only have Credo, same as NextLS. So we've talked about kind of what is, or what was. Now let's kind of talk about what's happened more recently. We have formed an official LSP team as of last August. This team is made up of Steve Cohen of Lexical, Lukasz Sampson of Elixir LS, and Jonathan Klosko from Livebook, and as well as myself from NextLS. Our goal is really to form just a tighter collaboration between the Elixir core team and LSP authors to really help provide better APIs from the compiler that can support editor tooling. So if the compiler can add more metadata into like the bytecode or give us functions to call to get bits of information. It just makes it so much easier. And our first project is kind of coalescing on a single language server implementation. Before we kind of get into this new coalesced server, let's kind of look through some of the core improvements that have even just happened in the last like 5 months. I heard some snickers. I hope it's about the photo. So one of the bigger innovations here is the concept of this compiler lock, which came out in Elixir 1.18. It allows for 2 beam processes to compile your code and put it in the same place without clobbering each other. All 3 of our language servers actually compile your code into a hidden folder inside your project. But like your Phoenix server is also compiling your code to the normal spot. So you're compiling it twice, because if you compile it to the same place, it kind of overwrites each other and just things get very weird. So this like has a compiler lock, so they can't like kind of work on the same thing at the same time and avoid duplicate work. There's also this concept of mixed listeners, so the language server can listen for compilation happening. So maybe your Phoenix server actually compiled the code before we tried to, and therefore if we didn't, we don't know, like our compiler tracers might not run. But with these mixed listeners, we can get that kind of notification that it compiled, and we can kind of get what we want. It's really useful for updating the symbol indexes and everything. This is done by Jonathan. He's done a lot of the core stuff. So here's kind of a demo. This is from Jonathan's pull request. It might be kind of hard to see, but in the top right, you can see a compiler running in mixenv dev, starting to compile, and you can see on the left here, right here, so this code is running at compile time because it's inside the module. It just sleeps for 10 seconds. So in the first one, it starts and then it just pauses because it's sleeping. Then he starts the second one, and it kind of just sits there because the other compiler has a lock on it, so it's just waiting. And eventually, did this stop or is it still going? Oop. Let's see if we can go one more time. Yeah, so he starts, and then it goes for lunch, and the next one starts, it kind of waits. The third one is actually running in mixenv dev, so it's completely separate from the other ones. And then you can see in the top one it finishes, and the middle one finishes at the same time because it sees, oh, that already compiled, like I don't need to do that anymore. So that's going to be very helpful. A lot of parser improvements also done by Jonathan. Having more metadata in the AST really helps just know where you are at in a file, and doing kind of like a lot more code mods. And I also added all these new features to the Spitfire parser. We have some new metadata in the docs chunk. This goes right in OTP actually, so it's not even an Elixir thing. Jose kind of pushed this forward. Currently the new behavior, but the new feature kind of is there's metadata about behaviors and callbacks, so we can be able to get that kind of like whenever we want and not like have to rely on compiling and that kind of stuff. So this is probably what a lot of you are really been looking forward to. It's about Elixir LSP. That doesn't really tell you much, so let's kind of transition to the real title of this talk that I was actually just too lazy to have them change, but now it works pretty well. I'm going to get this cool animation. So real title of this talk is Your Official Elixir Expert. Expert is the name of our new language server project. Thank you. We are merging the best parts of each server, so there are features like their multi-node architecture from Lexical and NextLS, a lot of the packaging and abstraction stuff from NextLS, the namespacing and a lot of like those completion kind of improvements from Lexical, and then just a wider set of features that come out of Elixir Sense that neither Lexical or NextLS support yet, just because we're so much newer and Elixir LS has really had a lot more time to think about those things. So let's kind of dive into kind of, because you're probably thinking why, like you made these new servers, like why is this really important? And here we'll kind of dive into some of these innovations and kind of like how they're working. So this diagram is showing kind of how the runtime multi-node architecture works. So your editor like NeoVim will boot up, and once you open an Elixir file, it will start the LSP for you over standard I/O. Our LSP application, the server part, all lives in this executable here, and inside of it, it has all the code to run this runtime node. So then it will, once it determines your current working directory and the path to your Elixir, so Expert is built with our Elixir and it's all portable, but we want to run your code in your Elixir. So it finds all that and it'll start this another Beam instance in a port. Inside there, it has the namespacing that I was talking about earlier. So like all of our runtime node files, like if the module starts with expert dot blah blah blah, or a dependency is sorcerer dot blah blah blah, those get namespace, so it's X expert and X sorcerer. That's not the actual how it works, but conceptually it's what you can think of, and that way we can run our own code and use our own dependencies, and they don't conflict with yours. Gen LSP is the process abstraction and kind of code gen LSP implementation I talked about. So it's actually generated from, the LSP has a JSON schema and a meta model. All the data structures are basically requests, notification structures, and enumerations. And that's all generated and uses a schematic to kind of map some of those things. The process abstraction basically gives you a gen server-esque API for listening to requests, listening to notifications, and doing things. It comes, one of the nicer things, it comes with the standard I/O, which is the most popular transport mode, and TCP, which makes developing on the server really easy. It's a lot more similar to working on your Phoenix server, where you just boot it up, and then your editor connects to it over TCP, and you can just iterate pretty quickly. With the code generation, like I said, we have the model and the meta model. The meta model is a JSON schema that describes a lot of the types that are used inside the actual model, like and type, array type. And the meta model code is handwritten, so that's just like I read the JSON schema and wrote the code, and it's used to generate the actual model for all the data structures. So this is going to be a lot, but I've broken up into two chunks. So this is an example of the mix generator, which is an EEX file. And you see the classic code gen, do not edit at the top, to generate the request data structure. So here you can see we get a lot of, so we design our name here, and then if this request actually has documentation in the model, we can actually make a module doc and put it all in there. We import schematic. We actually use type struct as well to just have dialyzer stuff. So here we get our method, and it has a JSON RPC field that's always 2, so you never change that. You got an ID unless doesn't have params, and then you got your params. And then requests also have results, so we have our result type here. Here's just further down in the code. Here actually defines the schematic. So the schematic is a schema, so that basically means struct for this module. It takes a blueprint, which is this map. It's saying we have a atom key, because it's structs only have atom keys of this, and then it puts it in there. Same kind of thing, like this is an int. And then params actually here, this will put the schematic for the actual param in the meta model. So then we also have the result, so this is one of, and then the error response, and then whatever the response actually is going to be. So let's look at what this actually looks like once it's generated. I shaved down the documentation and everything to make this a little easier. So here we see our schematic. This basically saying string literal means it needs to be this, needs to be this. ID is an int. Params are actually genlsp.structures.completionparams.schematic. So when it's validating this, it sees, okay, this is another schematic. I mean, this is just normal function. So after this is called. It's just like, one big like nested kind of description of what you want. And then here you can see this is one of, and then the first thing it can be of is also one of a list of completion items, or a completion list, or nil, and then or error response. And then we'll just kind of take a look at kind of a more advanced thing schematic can do. Here's the completion item, which is one of the, down here, it can be a completion item. So when it validates that, this one has a lot of fields, and a lot of them are optional. So here you can see it's a struct, obviously, with the module. And then here is where we do a lot of kind of making going from JSON-isms to Elixir-isms. So you can see that we are translating from strings to atoms, and then here we say this is an optional key of label details, camel case, but we want it to be snake case and an atom. And then each one of these things can also just be their own schematic, and schematics all the way down. And then one other interesting one is a lot of those you see are extracted schematics. So that means it's kind of like a type alias, and you're saying this like an apple is these things, rather than saying like just in place. So some of them actually have, like this one just says map. So it's saying like these change annotations are very loose description. The keys are of the change annotation identifier schematic, and the values can be of a change annotation. So it just it's called unifying, but it'll validate it to this kind of schema or schematic, as I like to say. And here we kind of go over the process abstraction that Next.ls is kind of built with. So it's very similar to a gen server. You see, use gen LSP, you got your start link, you got your init. We see an assign function, so the kind of the token state is called LSP, and you can assign to it. It's very familiar. And then here we just have different callbacks, handle request. It gets the request struct. It has all of this. It's all validated. It structs, gives you good, with your LSP, gives you good like key autocomplete support and all that kind of stuff. And you can hover on initialize result, and it gives you the docs for it. So it actually, and then because it has all those docs, they're pushed to hex docs, and it actually makes like exploring the protocol like a lot easier, in my opinion, because you're not looking at a big single web page that just has lots of vague descriptions. And here's just an example of like this hex docs shown through the app dash. If you're on Mac, I highly suggest get it. It makes searching hex docs really easy. And it kind of looks ugly, but that's just what is in the string in the protocol. So one of the big game changers for me is it's built with Burrito, built by Digit. He just gave a talk. He's awesome. He's somewhere around here. It wraps your project into a single executable binary, more similar to languages like Go, Rust, C. It automatically handles all operating systems, so it downloads statically linked builds of OTP for your target OS. So it can also, like from my Mac, I can compile ones for ARM Linux, AMD Linux, blah, blah, blah. It cross-compiles all your NIFs, so use SQLite, so it's very SQLite NIF, so it will pre-compile, cross-compile that for all the architectures, and it packs it all just into this archive in the binary. So this actually makes it very portable, and our server can rely on whatever we want to code with. We don't have to say, oh, people use Elixir 1.13, so we can only write code that works with 1.13. So here's just kind of like, I have lots of release automation. It uploads these pre-compiled binaries straight to GitHub release, very similar to how projects, like if you look at like Fuzzy Find, very popular FCF Go project, it looks just like this. It has like 30 more targets that they compile for, but, and here's just kind of an example of just how dead simple Burrito makes distributing Elixir applications. Here we just curl straight from GitHub, put it to a file by downloads called Next.ls. We make it executable and just run help, and it just it does some unpacking and puts into a cached area, and then it just works. It's just a CLI tool. The way the namespacing works from Lexical is actually not that complex. It's just pretty clever. You compile your code like normal, and it opens up the compiled Beam files, takes out the abstract code, kind of traverses it. It's actually very similar. It's not the AST, it's a little different, but it's very similar, and it just adds a known prefix to your Elixir and Erlang module names. It recompiles them back, packs them back in there, writes the new Beam files, and once they're all prefixed, you can just easily identify them and filter them out. So like they will still like be loaded when you get all the complete modules for completions, but you have a static way to say we don't want these, and that's kind of like what makes it. You can hack on expert with expert, and it won't recompile expert while you're experting on expert. So this is what I think everyone is really thinking about progress, like what's taking so long. Jeffrey actually said that to me as a joke yesterday. I thought it was funny, but it was funny because I was like, someone's gonna say that, and then he literally said it exactly that, but I thought it was funny. So combining 3 projects with various architectures and code style is harder than you'd expect, or exactly as hard as you'd expect. Don't let the people on Reddit fool you. Last year, I spiked out a new project to test how a GenLSP, Burrito, and Lexical namespacing procedure would kind of interact with each other. Got that working. Further, I spiked by copying in pieces of Lexical and pieces of NextLS that we wanted into this new project. Found points of friction and kind of foundational things we knew we'd want to make moving forward. So the current approach, and I'm sure you're happy to see some green check marks there, we actually are starting with Lexical, which we weren't going to do that in the beginning, and I think I told someone online that we weren't doing that, but then it ended up we were, so I'm sorry, person. Steve de-umbrellaed the project, turning it into a mono repo instead of an umbrella project. Apparently this is called a Poncho project. I had no idea. And kind of what's in progress now is to integrate GenLSP data structures and the process abstraction into Lexical. One little blocker on that is I need to implement async requests that kind of enable request cancellation, because the editor can make a request and then later if you hit Control-C or just like move to another buffer, like it doesn't need that hover, so it can just cancel it if you're, and we have an extremely concurrent runtime, so that's really easy. I just didn't need it in NextLS, but we need it to just be the best we can be. And after that, wrap it with Burrito. This was achieved during my spikes, but there was notable friction. Lexical is built with, they kind of like re-implemented mixed releases, but like slightly different, just to get it all to work, whereas Burrito is just a normal mixed release, and then it does the wrapping. But I did get it to work. And then just fill in missing features, because we're starting with Lexical, so we have all Lexical's features. We got to fill in the ones that are in NextLS or Elixir LS and are missing. So that's just shove them in there. For editor support, we'll support all major editors, but help from the community will be paramount. Like I use NeoVim, Lukash uses VS Code, Steve uses Emacs, so those will all have fairly first-party support. We'll create a brand new extension, and you can continue using the NeoVim Elixir Tools NVim plugin. I'll just switch it and we'll install Expert instead. We'll port all our documentation for all the other ones, but this is where the community will really help. Further improvements, this is pretty exciting. There's another LSP that was written called RefactorX. It's another language server by Gabriel Perea. As a university project, implements a ton of awesome refactors. It's actually built with GenLSP. It was wild to me. I'm on Discord. Some guy says, hey, I'm making my senior project. I'm using your library. It's really slick. It was unreal feeling. This is in progress. Here's just kind of a demo of from the RefactorX README of just some of the refactors. So here's one where we're converting from a shorthand anonymous function to a regular function. So here you can see highlight it, right click, expand, boom. Then here let's watch it again since it's a GIF and it's actually redoing it. Boom. Because sometimes you got those ones and you want to wrap it with a debug or whatever, and it's just a little annoying. Here's another one, extract name function from an anonymous function. So here, highlights it, right click, get your code action, click, give you a name. It prompts you for a name. I want to call it item price. Boom. And you can even see it saw that it's multiple clauses in the anonymous function, and it makes it multiple private function clauses. He implemented a, almost uses poor language there, a massive amount of these refactors. Some of them are only for a certain file. So like you might see we have like some rename ones in here somewhere. I can't find it, but those currently only work on the file, but combined with the index and everything we have, we will be able to hopefully do project-wide renames. Run low on time, so we're gonna kind of, there's not much more, but we'll kind of shoot through this. Future plans, project really needs to be fun and easy to hack on. That's kind of was one of the dilemma with Elixir LS, is no one enjoyed working on it. It's kind of a pain. I really want to make sure library-specific features and add-ons should be possible and easy to add. So, like Phoenix, Live View, Heek Sigil, like just works, like hover and all that kind of stuff, or ecto type, blah blah blah. And in general, just the community should feel comfortable that adding features and fixing bugs is possible. And if they're typing up, like they can just either make a bug report or maybe even fix it themselves, like right then and there. One note, Elixir LS actually implements the debug adapter protocol, which is a similar protocol for LSP, but for making like built-in IDE debugger integrations, like with breakpoints. Tentative plan is kind of just move it to its own project and kind of just work on it independently, because it shares like a little bit of code with Elixir LS, but not a ton, and it won't share any code with the new one. So if you want to follow along, check out this brand new website I built. It's absolutely beautiful, expertlsp.org. Let me know how beautiful you think it is. We have all the socials that you socialize on, and once we release this publicly, remember this is just a status update. Once we release it publicly, you will find it here at elixirlang/expert. So we are officially official. See this? That's Elixir. It's as Elixir as you can get. How to help? Sponsor us on GitHub. Money greases many wheels. We all have families and do this in our free time. So here are our links for me, Steve, and Lukash. And even kind of more importantly, after we release, use it, report bugs. Like, you can't get better if you don't report the bugs, and contribute. It should be fun, it should be easy, it should be a wonderful time. If you want to get in touch with me, you can go on my website, see what I'm up to. You can email me. I don't really do socials anymore, so that's why this has like nothing on it. And once again, I want to share, thank you, DraftKings. You can see here Ryan and Wei, really cool people. We are hiring, so please stop by. Love to work with you, and we have lots of amazing people from the Elixir open source community working for us, so thank you.
What an expertly done twist to the presentation. So I'm wondering, do we have any questions for Mitchell?
So you said that currently all of these LSPs basically compile to a folder there, but then you were hinting at this new compiler lock feature. Does that mean it will no longer compile to a folder?
Yes, so if your project is running on Elixir 118, we will be able to, feature switch on that and know we don't need to do anything special. We can just use the new goodies that you get from the newest Elixir. And it's always a incentive to update your projects. So we'll get
right. Yeah. So it's essentially all in memory, or are you still writing to disk somewhere?
We're just calling a normal mix compiler.
Cool.
And the mix compiler will just put it where it needs to go.
Oh, I get it now.
Yeah.
It's all the
so
same
before
place.
there's an environment variable called mix build root, and that's like where you want the underscore build folder to be. So we put that in our hidden folder. Instead, we just wouldn't set that, and it just compiles it where it wants to.
Awesome.
Any more questions? Yes.
Just trying to get the socials and the website. When's everything being launched for real, for real?
Repeat the question.
Oh, so Expert LSP just says coming soon. And the Blue Sky doesn't seem to be active yet. And the GitHub is still private.
Yeah, well, I said that's not public.
Yeah. So the question would be, when is it coming?
Soon. I said it was a status update.
Looking forward to it. Thank you.
Any more questions? Yes.
For others that want to help out, where is your like community hub kind of gonna be? Like have like a Discord or just GitHub issues down the line?
We're still kind of figuring out how to coalesce on where to congregate and hang out. We haven't settled on anything, but the thing is, like, I have my own Discord. Steve has his own Discord. There's the Elixir forum. So we don't know where we kind of want to, like, some people don't like Discord at all. Some, like, we like Discord. Steve used to work at Discord, so he really likes Discord. I think that we'll probably coalesce on one of our Discords, maybe, and then also I think hanging out on the forum is probably going to be a good way to congregate and make things as search engine searchable as possible. Because like it is true, like people come in my Discord, I help them with Vim. Like even if they don't use my stuff, I just help them with Vim because I have a Vim channel. But I answer the same questions over and over and over again. So having it just show up on Google and Elixir forum is a good place. And if you actually want to contribute, we'll probably just do lots of talking, like in GitHub issues and on pull requests and everything. So just don't be afraid. Dive in.
Cool. Thanks.
Yep.
Okay, so I think we are out of time for questions. So thank you so much, Mitchell, for the great presentation. So let's give a final round of applause.